Here's a small idea that may twist your mind a bit. If something can do anything at all, literally anything, can it create a rule it is unable to break? Sit with that for a moment, because the second it does, it stops being truly limitless. And if it can't, then it runs into the same wall anyway. That's not theology, that's logic. And once you see it clearly, it stays with you. But before we talk about God or logic or the universe, I want to begin with something simpler. How do you know what you know? Really think about that. You know the sun will rise tomorrow. You know that if you drop a ball, it falls. You know fire burns. But how do you know those things? Because someone told you? Because they seem obvious? Because you've always assumed they were true? The truth is, none of that is enough, not in science. Not if you actually want to understand reality, instead of just feel secure about it. Science is a very specific, almost stubborn way of knowing things. It goes like this. You observe the world carefully. You notice a pattern. You form a precise guess called hypothesis. And then, this is the key part, you try to prove yourself wrong. Not right, wrong. That sounds backwards, doesn't it? Why would you try to destroy your own idea? Because if your idea survives every honest attempt to kill it, every experiment, every test, every observation, then you've earned the right to trust it. Just a little. For now. Until better evidence arrives. That's it. That's the whole game. Now consider a thought experiment. Suppose I told you there's an invisible dragon living in my garage. You can't see it, can't touch it, can't measure it. But I know it's there. I can feel it. My grandmother told me. It gives my life meaning. What do you do with that? A polite person might say, well, I can't prove there isn't one, and that's technically true. But notice what just happened. I made a claim about reality and shaped it so that no possible test could ever challenge it. The dragon is invisible. It breathes heatless fire. It has no mass. The issue isn't that the dragon is improbable. It's that the claim was carefully constructed to be untouchable. And a claim that cannot be tested, no matter how sincerely believed, tells you exactly nothing about what is actually out there. This is what Feynman called one of the first great rules of clear thinking. If something cannot, even in principle, be tested, it is not knowledge. It is belief dressed up as knowledge. And belief is not a bad thing. People believe all kinds of things. That's human. But the second you say, this belief explains the universe, explains existence, explains why things happen the way they do, you've stepped into scientific territory. And scientific claims have to follow scientific rules. So, why does this matter for the bigger question? Because when we talk about God, an all-knowing, all-powerful being who made and rules physical reality, we are no longer talking about something outside the reach of physics. We're talking about something that supposedly acts on the universe, that intervenes, that causes events, and causes in physics leave traces. If something genuinely shapes reality, then reality should show it. We should be able to examine it. We should be able to test it. The instant you say, well, God works in ways we can never detect or measure, you've quietly, politely moved God out of reality and into imagination. That isn't an insult. It's just logic. And this is where our investigation really starts. Because the question isn't, do you believe? The question is, what does the universe itself demand when we look at it honestly? Let's find out. I want to tell you about something that stunned the smartest people in the world. And I mean that literally. When this idea first emerged in the early 1900s, physicists, brilliant, serious, mathematically disciplined physicists, looked at it and thought, that cannot be right. We must be missing something. They weren't missing anything. Reality was just stranger than anyone had been willing to imagine. Here's how it begins. Imagine you want to know where a moving car is and how fast it's going at the exact same instant. Easy enough, right? You look at it. You read the speed. Done. Now shrink that car. Not just small, absurdly small. Smaller than an atom. Down to the scale of a single electron. Now try the same thing. And this is where something profoundly strange happens. Not because our devices are bad. Not because our tools aren't advanced enough yet. But because nature itself imposes a hard boundary on what can be known simultaneously. This is Werner Heisenberg's uncertainty principle. And it says something that almost offends common sense. The more precisely you know where a particle is, the less precisely you can know how fast it's moving and the other way around. Not roughly. not because of sloppy measurement. Fundamentally, mathematically, inescapably. Now here's the thought experiment that really reveals it. To see an electron, to locate it, you have to bounce something off it. A photon of light, for example. But the moment that photon strikes the electron, it nudges it. It disturbs it. It alters the very thing you were trying to measure. You might think, fine, then use a gentler photon. Less energy, softer touch. But lower energy means a longer wavelength. And longer wavelength means a blurrier position. You've traded one kind of precision for another. There is no escape from this exchange. It is built into wave mathematics. It is built into the structure of reality. And here's the part many people miss. The uncertainty principle is not merely about ignorance. It is not saying the electron has a definite position and speed. We just can't measure both. It's saying something much more radical. Before measurement, those properties do not fully exist. The electron does not sit there with a precise location waiting to be uncovered. It exists in a spread, a probability cloud, a haze of possibilities. And only when you interact with it, only when you force a measurement, does reality appear to settle. Feynman himself described this as one of the central mysteries of quantum mechanics. Not a puzzle waiting for a neat solution, but a real, confirmed, experimentally verified feature of existence at its deepest level. Now hold that thought carefully, because this is where it connects to the larger question. If reality at its most basic level is irreducibly uncertain, if even nature does not know exactly where its own particles are until something forces a resolution, then what does that mean for an all-knowing mind, a being that supposedly contains complete knowledge of every particle, every position, every momentum, every quantum state all at once across the whole universe? The math doesn't allow it, not because God would need better tools, but because the information does not exist in the form omniscience would require. This is no longer philosophy. This is quantum mechanics, tested in labs, verified in semiconductors, lasers, and the screen you're watching right now. At its core, the universe runs on irreducible uncertainty. And a mind that knows everything precisely, completely at the same time, would have to know more than reality itself contains. Let's turn it into a game. Imagine you are the most powerful librarian in existence. Every book ever written, every fact, every number, every event is stored in your library. And not just the past. You know the present too. Every atom, every particle, every grain of sand on every beach, on every world, in every galaxy. You know everything. Now ask the question, can such a library actually exist? Not should it exist, not would it be permitted, but can it, given what physics tells us about information, reality, and quantum mechanics? Let's see, because the answer is more surprising than you might think. We already established something crucial. At the quantum level, the deepest level of reality we have ever examined, particles do not carry complete, precise information about themselves until they are measured. An electron does not have a definite position and a definite momentum at the same time. That information, in the classical sense, simply is not there. But let's go further. Feynman gave us something extraordinary, a way to think about how particles actually move through the universe. It's called the path integral formulation, and it changes the way we picture reality. In plain terms, when a particle goes from point A to point B, it does not follow one path. It follows all paths at once. Every possible route, every wild loop, every backwards, impossible-looking trajectory. The particle, in some valid quantum sense, explores them all simultaneously. These paths interfere with one another like ripples on water. Most cancel out. The ones that survive, the ones that add together constructively, produce the path we actually observe. Now pause there. This is not just a metaphor. This is not a convenient mathematical trick we use, because it gives the right answer while something simpler secretly happens beneath it. This is what is happening. This is reality. So ask yourself, what would an all-knowing mind have to keep track of? Not just where every particle is now, but the full quantum state of every particle, its superposition, its entanglement with every other particle, its complete spread of probabilities across every possible configuration. And here's where it becomes truly staggering. The number of particles in the observable universe is estimated at around 10 to the power of 80. That number is already beyond normal comprehension. But the quantum state of a system does not grow in a neat linear way with the number of particles. It grows exponentially. 2 entangled particles? You need to track not just each one, but the combined state of both. Add a third, and the complexity doesn't merely increase. It explodes. To hold the complete quantum state of the universe in one mind will require a storage capacity larger than the universe itself. The information simply has nowhere to go. Now, someone may say, well, God exists outside the universe, beyond space, beyond physics. And I want to take that seriously, because it deserves a serious answer. Answer: if a being exists outside physical reality, outside space, outside time, outside quantum mechanics, then by definition it does not interact with physical reality. It cannot cause events, cannot intervene, cannot answer prayers or steer outcomes, because causation, the ability to make things happen, requires being part of the same physical framework as the things being affected. You cannot push a door open from outside the universe. So we reach a real fork in the road. Either God is within physical reality, in which case the mathematics of quantum mechanics applies, and omniscience becomes computationally and physically impossible, or God is completely outside physical reality, in which case the connection to our universe is cut off, and the word God no longer describes anything that acts, creates, or matters in any physical sense. Both paths lead to the same place, not to a lack of wonder, not to a lack of mystery, but to the quiet, uncomfortable realization that the universe, on its own terms, by its own rules, leaves no room for the blueprint. Here's a question that sounds like a riddle, but isn't. Can an all-powerful being create a stone so heavy that even it cannot lift it? If yes, then there exists something it cannot lift. It is not all-powerful. If no, then there exists something it cannot create. It is not all-powerful. Either way, the idea breaks apart from the inside. You've probably heard that one before. It's old. Philosophers have argued over it for centuries. Some have elegant replies. Some redefine the terms. Some say the question is malformed. But here is what is different when physics takes a look. We are not going to argue definitions. We're going to see what the universe itself demands, mathematically, physically, logically, and follow that wherever it leads, even if it is uncomfortable. Start with something concrete. In physics, we have laws, not suggestions. Laws. Conservation of energy. The second law of thermodynamics. The speed of light as an absolute limit. These are not rules somebody wrote down and pinned to a wall. They are deep structural features of reality, so fundamental that everything we observe obeys them without exception. Now here's the real question. Can an omnipotent being break them? If it can, then those laws aren't really laws. They are just habits the universe keeps until something stronger decides otherwise. And if that's true, then physics, all of it, becomes meaningless. Any result, any experiment, any observation could be quietly overridden at any time. Science would become impossible. Prediction would become impossible. Reality would turn into a performance with a hidden director rewriting the script mid-scene. But if an omnipotent being cannot break the laws of physics, then it is not omnipotent. Something limits it. Something stands above it. And we are trapped again. Here's another route, and this one comes from the mathematics of logic itself. In 1931, Kurt Gödel proved something that shook mathematics to its foundations. He showed that in any sufficiently complex logical system, any system rich enough to describe basic arithmetic, there will always be statements that are true but cannot be proven within that system. You cannot build a system that is complete enough to prove every truth about itself. Now carry that into the idea of omniscience. An all-powerful mind, one that knows and controls everything, will have to function like the ultimate logical system. Complete, consistent, total. But Gödel tells us that completeness and consistency cannot both survive in any sufficiently powerful system. The moment a system becomes rich enough to be meaningfully omnipotent, it also becomes rich enough to contain truths it cannot reach, conclusions it cannot fully justify, an irreducible incompleteness built into the architecture of total power. Omnipotence, if taken seriously and mathematically, does not merely struggle under pressure. It collapses under its own weight. Now I want to be careful and honest. These arguments do not prove that nothing exists beyond what we can measure. They do not close every door on every version of every idea humans have ever called God. What they do, very powerfully, is show that the specific idea of an all-powerful, all-knowing being that acts on physical reality is not just unproven, it is internally inconsistent. Not because we lack imagination, but because logic and mathematics are unforgiving like that. They do not care what we prefer to be true. They follow the structure of reality. And reality does not bend for comfort. And there is something almost beautiful about that. Because a universe ruled by honest, unbreakable logic, a universe that refuses to make exceptions even for infinity, is a universe you can actually rely on, not because it is kind, but because it is consistent. And consistency, it turns out, is rarer and more valuable than miracles. I want to tell you something that may sound strange at first. The most intellectually courageous thing a human being can say, after everything we've explored today, is not, I know. It is, I don't know. 3 words. Simple, quiet, and almost nobody says them anymore. Not with real ease. Not without quickly filling the silence with something more certain, more polished, more satisfying. But here's what I have come to believe after following physics honestly wherever it goes. Uncertainty, when held carefully and openly, is not weakness. It is the beginning of every true thing we have ever learned. Think about how science actually advances. It does not march forward on certainty. It stumbles forward on doubt. Newton looked at the sky and said, "I think gravity works like this." And for 200 years, he was right. Brilliantly, usefully, magnificently right. Bridges stood. Planets moved on schedule. Cannonballs flew along the predicted arc. Then Einstein looked more closely and said, "Not quite." Not because Newton was foolish, but because honest observation, pushed far enough, always finds the edge of the current picture. And at that edge, if you are brave enough to stand there without flinching, that is where real understanding begins. This is what separates science from dogma. Dogma starts with the answer and works backward. It picks the evidence that fits, quietly ignores the rest, and calls the result certainty. Science starts with a question. It follows the evidence especially when the evidence leads somewhere uncomfortable. And it keeps its conclusions loose, always ready to revise, always aware that the map is not the territory. Now here is the deeply human part. We are not naturally built for this. Our brains want closure. They detect patterns even in noise. They would rather have a story, even a false one, than an open, unresolved question. Religion understood this long before psychology did. But here is what physics offers instead. Not false comfort, not a story built to soothe, but something rarer and, in my view, far more extraordinary, the actual universe. Consider what honest science has already revealed without inventing a single convenient answer. Space and time are not fixed. They are woven together and can bend. Matter is mostly empty. Light behaves like both a wave and a particle, depending on how you examine it. The universe began in a state of almost unimaginable density and has been expanding ever since. And the expansion itself is speeding up, driven by something we can measure but do not yet fully understand. We call it dark energy. We do not fully know what it is. And that is okay. That is honesty. That is where we actually are. The willingness to say we do not know yet, and truly mean it, is not a failure of science. It is science working exactly as it should. Because every we don't know yet in history has eventually opened into something astonishing. Not always what we expected. Never just what we wished for, but something real. Something that held up under pressure. Something you could build on. False certainty gives you comfort today and collapse tomorrow. Honest uncertainty gives you something real to pursue. A thread to pull. A question you can actually follow. A door that might truly open. And so, after everything we have walked through today, the uncertainty principle saying reality itself is fundamentally fuzzy at the base level. The path integrals showing particles explore all possibilities at once, the logical contradictions built into omnipotence, the mathematical impossibility of total knowledge in a quantum universe. What do we conclude? Not that the universe is empty of meaning, not that wonder is unwarranted, not that the questions people have carried for centuries, Why is there something rather than nothing? Why do the laws of nature exist at all? Are foolish questions. They are magnificent questions. But magnificent questions deserve honest answers. Or, when honest answers are not yet available, they deserve the integrity of admitting that plainly. The universe does not owe us comfort, but it rewards curiosity, consistently, generously, without exception. And if you've stayed with me through all of this, through the quantum mechanics and the logic and the mathematics and the doubt, then you already know what that feels like. That quiet, electric sense of following something real. Hold on to that. It is the most valuable thing physics has ever given anyone. So let's tie it all together. We began with a simple but ruthless question. What does it actually mean to know something? And we found that real knowledge requires testability. It requires the courage to be wrong. A claim that cannot be tested, however sincerely held, however beautifully expressed, tells us nothing about what reality actually contains. Then we went deeper. We found that at the most basic level of physical reality, smaller than atoms, smaller than protons, down at the quantum scale where the universe writes its own rules, nature itself is governed by irreducible uncertainty, not because our instruments are poor, but because a precise form of information that omniscience would require simply does not exist. Heisenberg did not merely uncover a limit on measurement. He uncovered a limit in reality itself. Then we followed Feynman's framework, the path integral, and found something even more astonishing. Particles do not travel one path. They travel all paths. The universe at its core is not a clockwork machine with every gear position accounted for, but a vast shimmering web of probabilities, becoming definite only when interaction forces a result. To know the system completely, every quantum state, every entanglement, every superposition across 10 to the power of 80 particles, will require a storage capacity larger than the universe itself. Omniscience is not merely unlikely. The universe does not contain enough room for it. And then we turned to logic itself. We found that omnipotence, true, total, unlimited power, breaks under its own definition. That a being powerful enough to violate physical law makes physical law meaningless. That a being constrained by physical law is no longer omnipotent. That Gödel's incompleteness theorem quietly echoes the same uncomfortable truth from the foundations of mathematics itself. No system powerful enough to be total can also be complete. Infinite power, when examined honestly, does not stretch forever. It folds back on itself and breaks. And finally, maybe most importantly, we sat with doubt, not as failure, not as weakness, but as the only intellectually honest response to a universe this strange, this layered, this genuinely surprising at every scale we've ever managed to probe. Science does not promise comfort. It promises something better, accuracy, a picture reality that holds up under pressure, that survives every sincere attempt to break it, that earns your trust not by asking for it, but by delivering results again and again without exception. The universe does not need an architect hiding behind the blueprint. It is the blueprint, written in mathematics, expressed through quantum fields, encoded in the behavior of light and matter and space and time themselves, and that, if you ask me, is not a smaller thing than what was promised. It is something vastly larger. Now I want to be straight with you as we close. These arguments are not the final word. Science rarely gives final words, and that is exactly what makes it trustworthy. There are physicists and philosophers who would challenge parts of this. There are still open questions at the edges of cosmology. Why is there something rather than nothing? Why do the laws have the form they do? That remain beautifully unresolved. We should keep pulling those threads. Always. But what we can say with strong confidence, with mathematical and physical support, is this. The specific God of total knowledge, total power, and active intervention in a quantum universe is not merely unproven. It is boxed in by its own definitions, trapped between logic on one side and physics on the other. And the universe, honest, consistent, merciless, magnificent, offers no exit. If this kind of thinking excites you, if you like your physics clear, your questions real, and your answers earned rather than handed to you, then you're exactly who this channel is for. Hit subscribe, because we're only just beginning. There are ideas ahead that will challenge you, surprise you, and if you stay curious enough to follow them all the way through, change the way you see everything. And isn't that exactly why we're here? And that's it. Honestly, thank you. Really. Not in the automatic, expected way people say thank you at the end of something, but sincerely, because you stayed. You followed the argument all the way through. You didn't walk away when it became uncomfortable or strange or a little mathematically inconvenient. That takes a particular kind of mind, a curious one. And curious minds are, in my experience, the best company there is. You know, what I love most about these ideas is not that they hand us answers. It's that they teach us how to hold questions properly, without flinching, without rushing to fill the silence with something comforting. That's a rare skill. And the fact that you're here, watching a video about quantum mechanics and logic and the nature of reality on what I assume is otherwise a perfectly ordinary day, tells me you're already practicing it. So keep asking the uncomfortable questions. Keep following the evidence, even when it leads somewhere unexpected. And keep that quiet, stubborn willingness to say, I don't know yet, because that phrase, more than any other, is where real understanding truly begins. I'll see you in the next one.